Hey everybody, this is Kai Wehner from Confluent. Today I want to talk to you about event streaming in the telecommunications industry. I will discuss 10 different characteristics of why more and more projects in telco business leverage Apache Kafka and its ecosystem. First of all, let's understand the basic subject of telco business. We always talk about BSS and OSS, business support systems and operations support systems. That's how telco business typically is separated when you talk about the projects. And then, of course, you have to integrate both of them. And in addition to this, which typically is deployed in data centers, so I'm saying here data center 1, 2, and 3. However, on the other side, we are of course seeing more and more movement to the cloud. This can be something like AWS or Azure or GCP, or maybe even something like Alibaba in China. Or often also it's multi-cloud, so several of the different clouds are used for different projects or hybrid architectures. With this basic understanding of what how the telco business is separated, let's now think about many different use cases which I see implemented with event streaming. First of all, let's start on the OSS side. So this is low level where you integrate with all the networks and devices and firewalls and the data centers and at the edge. And here we do things like monitoring. Monitoring means that you have to integrate to many different technologies and interfaces. This can be something like syslog or TCP or different messaging providers, for example, a JMS implementation like IBM MQ or RabbitMQ, or whatever is used at the edge for all the messaging and creating logs and other information in a streaming way. So this is integrated often with event streaming for real-time monitoring. This is the first important thing. And here you don't just send the data from A to B, but you also correlate the data. For example, you filter out data or you aggregate different information from different interfaces. And then in the end, the final goal obviously is things like alerting, so that you can act if there is a failure, or sometimes even you want to act proactively. With this first use case, we already see two characteristics why people use event streaming so much. First of all, let's understand that the first requirement here is real time. I think that's clear for this kind of sensor information, but we see more and more requirements for this also on the BSS side for building new business applications. This actually in telco is not really something new, so a lot of MQ systems do this for a long time. However, with this also, we see the second requirement, which is very important, and this is scalability. So scalability is something which comes up more and more because more and more devices and machines and sensors and mobile smartphones create data. So you have to scale up much more than in the past. And this combination of scalability and real time is the first big reason why people in telco business use Apache Kafka for event streaming more and more. Because you can't do that with traditional messaging systems. So you can also start small and scale up like crazy. We have different clusters in Confluent Cloud where customers use one single Kafka cluster and ingest over 1 gigabyte per second and egress over 4 gigabyte per second. So that's pretty easy, even if you start with maybe 1 megabyte per second throughput. This is the first big use case. However, of course, there's much more. In addition then to monitoring, another thing you want to do is security. So something like theme or other security related implementations. This means that you get all the ingested data from the syslogs and so on, and somehow you also want to correlate the data and get more input out of that. So in addition to some pre-processing, which we already did for monitoring, you want to detect things like fraud or incidents in the telco infrastructure all over the country and at the edge, in the hardware devices, firewalls, and so on. So this is another big thing. And by the way, of course, this is often not just done by event streaming and Kafka alone, but this is done often together with other solutions. So just to mention Splunk as one big example, which many telco companies use, or maybe something open source like Elasticsearch. So event streaming doesn't solve all problems, but it's often a core of the infrastructure to help with solving problems. So this actually brings me to the next characteristic, why people use event streaming here. Of course, you could ingest everything directly into Splunk, and some people do in the beginning. However, big other use case is cost reduction. So more and more people use event streaming with Apache Kafka ecosystem to filter out data before they send it to technologies like Splunk, because simply of reducing cost. This is a very common use case for SIEM and security, using event streaming before that. Another use case is where traditional SIEM and security solutions like ArcSight don't scale well, and therefore you combine it with event streaming. But cost reduction in addition to scalability is a big reason here in this case. With that, this is just one example of how you can use event streaming at the edge in OSS. However, now let's move up a little bit, because more and more telcos need a strategy how to do communication between BSS and OSS in a scalable and reliable real-time way. So now let's talk about, and let me change the color here, let's talk about event streaming as core of the business here between BSS and OSS. Central event streaming. So this is something which comes up more and more because you need to communicate well between OSS and BSS. So this is also nothing new. This has had to happen in the last years, but more and more challenges happen because this has to happen at a much bigger scale than in the past and still reliable. And therefore, event streaming with Kafka comes up here more and more. This brings me to one of the most important characteristics why we see people working with Confluent when they think about building such an event streaming platform as central ecosystem, and that is 24/7 reliability. And that's huge for many telco use cases, right? Here you have to think about things like RTO and RPO. This means in the end, how much time can you survive or should you survive if your infrastructure is down, if a disaster happens. For example, if one of your data centers is down. And we see more and more use cases where even you have to get a zero downtime and zero data loss. And this is possible with Kafka if you use it in the right setup with the right tools and monitoring infrastructure around it. So we have many customers which setting up stretch clusters and multi-data center replication to build a highly available Kafka cluster with zero downtime and zero data loss. This is definitely the most challenging Kafka deployment and not required for every use case. But here, as central event streaming, this is really critical, and therefore it should never be down, not even for an hour. And that's where people come to us to get our help building such an infrastructure. So here now we have the central core event streaming between OSS and BSS. With that, why do people do that? Because in BSS, they want to build business applications. So once again, I need to change the color. This is in the end business applications. Let me do that also in blue, because event streaming is not just used on the server side. So this is very important to understand. So if you leverage Apache Kafka, you also build the client side in a highly scalable, highly reliable, and real-time processing way. So examples here are, for example, Customer 360, where you want to correlate all the different data from customers and act in real time. This can be things like billing, or this can be things like recommendations, for example, for personalized offers to the end customer. There are many use cases for business applications here. And this actually brings me to the next big point why so many people use Apache Kafka. So the big point here is decoupling. So this is a huge point why people use Kafka instead of something like traditional messaging or traditional middleware. Every microservice architecture you build is built with Kafka in the meantime, because it decouples the different systems. And there is huge advantages here. So first of all, and that's what many people are not aware of, Kafka is also a storage system under the hood. And with this storage system, which I write here as characteristic of number 5, you can decouple the different clients from each other. This is both producers, like here in OSS, syslog systems, and all the different consumers. They are all decoupled. One application could be a real-time fraud detection application or billing application to process the fulfillment of the orders. Another one could be a big data batch analytics process. They are completely decoupled from each other because Kafka in the middle also stores the data. And so with this, you really decouple systems. This is very different from other middleware architectures where you use just a queue, where the data is consumed and then it's removed from the queue. Or very different from a web service where you have synchronous communication and not really decoupling from each other. And this is really huge. And with this, as other part of this characteristic, you can really build domain-driven architectures, domain-driven design, where each application or microservice is completely separated from each other. This also means that you can use different technologies for the different microservices. And the third part about this is, as you store the data, you can also reprocess it all the time. This is huge for different use cases. For example, if you build a loyalty system for your customers and you want to reprocess the data to make the right recommendations. And this is just one example for reprocessing data. Machine learning is another good example where you want to consume the old data again to train another model by the data scientist. This is also a good example where different technologies come into play. The fraud detection app might be a Java application, the recommendation system might be something in .NET, and the data scientist obviously uses Python to consume all the same data from the same central event streaming technology. And this is what we provide from Confluent with some open source connectors and open source clients. And also there's, for example, a REST proxy if you want to do request-response communication with Kafka. So decoupling is really a big part even if you don't use Kafka for big data. So that's important to understand. Even in telco business, more than 50% of the projects with Kafka are not about big data, but really it's more about critical business transactions. With that now, let's also think about other things which customers build. It's not just about business applications in BSS. It's also really about platforms. Once again, sorry for the wrong color. Once again, here it's platforms. So platforms means things like a connected car infrastructure, for example, for the manufacturers or for the retailers, connected cars. Many telcos in the meantime build an infrastructure for this because they have the network. And in the future with 5G, this will even get more important for telcos. Another example on the same idea is for smart cities, where telco business works together with cities to provide a scalable real-time infrastructure, still decoupling all the different applications, but also then using the data the right way. And the third example here is media. So I work with telco customers which also have a big media business. So in addition to customers like Netflix, which is only media, right? Also, and they are also heavy Kafka user for these reasons. Also all the telco businesses which have media services use Kafka here because they need to integrate with different devices like mobile apps and TVs, but also they have to integrate many different technologies. And that's where event streaming comes into play more and more. And with this now, what's important to understand, it's not just about real-time streaming for messaging, it's also about processing the data. Think again about the recommendation engine. Here you also have to communicate with your CRM system to correlate the information. Or let's assume that you have a sports event. A sports event also has external information, and so you have correlate all this data and process it together in real time at scale to make the right recommendations and user experience to your customers. Like on a mobile app, you can send a push message to do cross-selling if the customer is in the stadium and you want to sell him something with a coupon or something like this. So this is the sixth big characteristic of why people use Kafka for event streaming and not just a messaging solution or other middleware. The key part is you also do processing of the data in real time at scale. And this also includes stateful clients. So that's very important to understand. A client is not just a consumer, it's also processing the data and can keep the state of the information in Kafka. This makes it very powerful and scalable end to end. With this now we understand the relation between OSS and BSS and why Kafka is used everywhere. As next part, however, it's important. This is also true if you work with external partners. So external partners. External partners is another big example where people use event streaming. And this means that we also communicate from our business with other businesses. So it's not just the end consumers, but many partners. So in the end, what you provide is some kind of API between Kafka and your internal systems and the external world. And this obviously could be something like a REST proxy from Confluent, which can be used to do HTTP communication and provide an API to the outside world to produce and consume messages. But we also see even this more and more in a streaming way, where data is replicated between different partners in real time at scale. This is often a ridiculous situation when different partners both use event streaming and Kafka under the hood internally because they need it for all these reasons discussed here in green. However, in between these two partners, they still use a REST API and web services, which don't scale well and are not real time. This doesn't make much sense, right? So more and more partners use streaming in between their interfaces, which makes a lot of sense. But you can also use APIs if you want to. Now, with this understanding, let me also talk a little bit more about the central event streaming. Because what's important, of course, so there is already a requirement for integration in the last 10, 20 years for telco business. So every telco business has a lot of legacy apps, right? So this can be something including mainframes. This can be something like an ERP system. This can be something like old databases or whatever. And today already customers have middleware in place. Of course they have, because you also needed to integrate in the past. This can be things like TIBCO or IBM or many others. So these are already used to integrate with legacy middleware, and that's what they work well for. However, they are not really built for building this central integration system at scale in real time, both together. That's where most traditional middleware struggles. And then also run this 24/7 with zero downtime and zero data loss, and with doing decoupling between all the different systems. So this is really hard to do, and this is really where Kafka shines. However, of course, you cannot simply replace every existing infrastructure with Kafka. So you're not starting from greenfield like maybe Netflix did 10 years ago. They built everything around Kafka. You in telco probably can't do that. So what we also see a lot, and that's very common in all the telco business, is that we also integrate with traditional middleware. So this is a very common scenario in both directions. Therefore, the big next characteristic why we see people using Kafka is also for integration as next generation middleware. Because you can integrate either directly with legacy systems. So we have customers pushing data with change data capture directly from mainframes or databases into Kafka to process it with other systems, and also to integrate it with the modern world and new technologies for big data and machine learning and so on. However, we also integrate with the middleware. So in the meantime, either you use Confluent connectors, for example, for IBM MQ or TIBCO, or for a database, or you use the connectors from the traditional middleware. All these middleware vendors have Kafka connectors in the meantime. It's not because they want to do, but because they have to integrate with the modern world in both directions. There is no option not to doing that, because otherwise the traditional middleware has to be replaced. And in this way you can even use it like it is today and combine it with the modern world. So this is a critical part of the telco infrastructure, and to understand that event streaming and the Kafka ecosystem is complementary to a legacy and existing middleware, like it is complementary to Splunk and other tools. With this understanding now, after we discussed OSS and BSS, and also the integration between OSS and BSS and other technologies, we have one more important point to discuss. Because on the right side you see, we have the cloud. And all the telcos in the meantime have a cloud strategy. This doesn't mean everything is going to the cloud, because you can't move all your local things away, and some things need to be processed at the edge for a long time or even forever. So for this reason, we also have cloud event streaming. So this is separated from the local processing, right, at the edge or in the data center. Here you are in one or more clouds. And here you build often other applications, for example, for monitoring or for analytics, or other business applications like microservices, where you build your cutting edge new customer interface, or any other fraud detection application on big data analytics with machine learning. Whatever you build, the point here is you can either build it just with Kafka, as I discussed, with Kafka native technologies like Kafka Streams or KSQL, or maybe any other Kafka client like Java, .NET, Python, or Go. Or obviously, you can also integrate again with other systems. Like this can be something like your data lake in the cloud. Or this can be your data warehouse, something like Snowflake, which is a cloud-only data warehouse more and more people use. Or you leverage the machine learning services from the cloud providers, where, for example, Google or AWS is very strong in. And so you connect these both worlds. So the point here is this can either be completely separated projects, but in the real world, often this is correlated to each other, right? Because you want to communicate between data centers and the cloud. And what's better to also use the event streaming replication technologies to do this at scale in real time, but still decoupled and highly available. With this, we come to the 8th characteristic why people use event streaming with Kafka and Confluent: hybrid architectures. Most of the big customers and Fortune 2000 companies have hybrid architectures. They are on-premise and they are in one or more clouds. And so hybrid means things like cloud, but this, like cloud, but also data center or edge, and obviously also multi-cloud, right? So this is the main idea why Kafka is so strong here, because you can use it in both directions. You can use it in the cloud, in different clouds, on premise, at the edge, all with the same technology. So I've seen many customers which have built one template based on Kubernetes, for example, which they roll out in their data centers, but also on different cloud providers in the same way. However, then, if you talk about cloud specifically, there's a big other advantage of using Confluent. So here you see the 9th important thing, which is fully managed infrastructure for event streaming. So if you go to the cloud, of course, you can self-manage it. But we see more and more customers which say, well, we want to leverage event streaming. We want to use it in a consumption-based way, only pay for what we use. We want to have it with SLAs, mission critical, highly available, with all the ecosystem around it for processing data, for integration into the cloud storage, for example. And therefore, they use it as a fully managed infrastructure provided by Confluent on all major clouds with consumption-based pricing in a serverless way. And be careful here, because many vendors have marketing for fully managed services, but actually they only provision the brokers for you, and you have to do all the fine-tuning, bug fixing, upgrades, and so on. So really compare the different cloud solutions if they are more serverless and fully managed or not, because I can tell you most are not fully managed, only Confluent Cloud is. So this is another big characteristic, but now let's think one step further. Not everything is in cloud, as we said. So we also have another big point, which I didn't paint here, which is actually the edge. And the edge is everything not in cloud, but also not in the data centers. And therefore, there's many different scenarios what edge can be. So you can use edge event streaming for many different use cases. And in telco business, I have seen many different things of what edge is. Some customers define edge really just as differentiation between their different opcos in the different countries. And they have one infrastructure in one data center in each opco in each country. However, besides that, another characteristic is where we see edge processing, for example, in the retail store of the telco provider. This is really at the edge because you have hundreds or even thousands of retail stores, and many people now use event streaming more and more at this edge so that they can use the same technology in all the different infrastructures. Of course, at the edge, this is just a very small cluster, or sometimes it's even just one single broker, which doesn't have high availability, but it's often good enough, for example, to do edge processing, like in a retail store where you want to correlate data in real time and store it. And at the end of the day, or maybe in real time, you replicate this edge data also to the cloud. So this is a very common scenario. So let's assume we have many different retail stores, and they also do some local processing like recommendation to the customer while he's walking to the store. So this can happen at the edge in milliseconds. However, you aggregate all this data in a big event streaming cluster somewhere in the cloud or in a data center. This is also a very common scenario. And with this, I want to come to my last characteristic, with why people use Apache Kafka and its ecosystem. And this is no vendor login. So this is really huge, because with this, you can start with an open source project Still get all the SLAs and tools for supporting that, mission critical, but you can run this everywhere, on premise, in OSS, in BSS, for the integration between OSS and BSS, for edge deployments, and then also in the cloud. And also integrate all of them just with Kafka technologies. And there is a lot of important products and technologies around that to do that really mission critical. Because just using Apache Kafka and telco doesn't mean it's mission critical. This is really the hard part where you need the expertise and the right tooling. So Confluent, for example, provides tools for multi-data center replication so that you can build a big cluster even over different regions to guarantee zero data loss and zero downtime. And that's where we are here to help, both on-premise, in the cloud, and at the edge. So I hope this was a good overview about Kafka and event streaming in the telecommunications industry. If you have any feedback or questions, please come back to me. Thank you for watching.